research is actually motivated, probably a little bit different than some of the ones already presented in the day, um, because I teach at the University of Miami, here in Miami, Florida, in the States, and I teach a class on symbolic reasoning, where I typically expose my students to, the good old-fashioned AI, and I teach them classical languages like Prolog and a couple of equivalent ones. I also teach them um, kind of like the way that artificial intelligence was basically conceived from the very beginning of its creation. But simultaneously, I also teach a class on machine learning, and uh, everybody knows that the shift it's totally different, and it's obviously more inspired on understanding neural networks, super vector machines, and typical older, more numerical based algorithms that change in the way that we conceive artificial intelligence. So last semester, one student in particular asked me, Professor, I'm in both of your classes. I'm enjoying your class in which you're teaching symbolic AI, super cool topic, amazing. I'm enjoying this class too, where I'm exposed to machine learning. But, is it possible to integrate both worlds? Is it that they are divorced? What is the mentality on the community, on the scientific community about AI being seen from the symbolic and sub-symbolic representation? And that kept me thinking. That kept me thinking for a long time. And I obviously went back to research. I wasn't even able to give my student the best answer right on class, but that actually lead to this paper. So this paper is titled Fuzzy Cognitive Maps as a Bridge Between Symbolic and Sub-Symbolic Artificial Intelligence, because that's the way I see. I see the future of artificial intelligence being more like a hybrid approach and not necessarily a divorce in between a symbolic and a sub-symbolic representation of problems, and not necessarily different approaches in the way that we're tackling problems. Just to give you some context, so to anyone in the audience that might not be familiar with the differences, even though I presented in the motivation in the opening of my presentation. Symbolic AI relies on working with symbols, logical representations of problems, and it has been really well studied for many decades. And it's also well known that sometimes when we are trying to analyze problems characterized by a lot of ambiguity or uncertainty, this approach is not the best one working for some of the theoretical considerations in the back end of this proposal. Sub-symbolic AI or machine learning, on the other hand, kind of like co-created probably to tackle these limitations in the symbolic AI that I told you about. And it has been very popular about identifying patterns in everything related to pattern recognition, also predictive modeling, and definitely trying to work in scenarios where we have a lot of uncertainty, or we simply have the data, but we don't have necessarily the reasoning behind, and we simply let the computers figure out better ways into getting into a conclusion similar to how we do decision making on a daily basis. I also want to add that the advantages of symbolic AI are very well known. For example, one of the highlights is their ability to explain the reasoning. It's something that is coming back, I guess. Is very attractive to be working with models that have the ability to explain how a decision-making process was actually made. Also, symbolic AI, it's proven to work very effectively in certain specific domains where the data is very well labeled and very well studied, and experts have been able to document problems correctly in a way that we can program it with logical reasoning. Symbolic AI, as said, is very well known for formulating clear rules, for creating relationship among the data being represented, and therefore it's a very attractive approach anytime that we need to actually trace a system reasoning and potentially explain to anyone how a decision making was done internally from a system perspective. When it comes to symbolic artificial intelligence, sub-symbolic artificial intelligence, the advantages rely on a totally different perspective. Even though the system might not be able to explain exactly how every single decision was made, the advantages are coming from a different dimension. For example, it's almost impossible to be feeding symbolic AI system with enormous amount of data and expect that these systems are going to learn by itself, but sub-symbolic artificial intelligence actually tackle that problem. So learning from data is one of the first advantage I can think of. Even high-dimensional data, complex data, even for the human to analyze with our own eyes. Computers in the machine learning area has proven to work even better than humans at analyzing enormous volumes of data, and even generalizing, trying to aggregate the data, simplify it in a way that then systems can execute it properly, and even reduce the dimensionality in the certain data sets that could contain observation from years of any situation being documented from the industry. And one of the biggest advantage of sub-symbolic AI, it's the handling of ambiguity or uncertainty, which is something that sometimes symbolic AI struggles. It's not impossible to be done, but struggles from the very core of that technique. But certain others in the sub-symbolic AI have been created totally to handle ambiguity, which really represents the way that problems are happening on a daily basis. And we humans have been dealing with ambiguity from a long time, every time that we are doing decision making. So having computers doing this is actually fascinating. Obviously, both paradigms do have their challenges as well. And specifically in the symbolic AI, there is an enormous bottleneck every time that we have to acquire knowledge. Most likely the knowledge is coming from human expert, and we already know how difficult it is to make a human expert express all of their knowledge to be documented into a program. Say that imagine you're trying to tell a doctor in the medical area, please explain to me how you are making a diagnosis of a cancer illness, and what would be the best treatment for the patient, just using a fictional scenario. And you might see even the doctor struggling to explain the whole reasoning mechanism. So imagine how difficult it would be to program it into a system to be acting as a human expert. It's a very well-known situation. Also, symbolic AI sometimes struggle with their flexibility. Once a rule is being created, once certain programs have been created and programmed, sometimes they do not adapt well to newer circumstances. And the world, it's full of circumstances, so that will create definitely a problem, having a solution that doesn't have the ability to adapt to other situations. On the other hand, sub-symbolic AI, it's very criticized. There are many famous techniques, just to mention one of them, classical neural networks, highly criticized because they are acting most of the time as a black box problem or a black box classifier, which simply means that data comes in, solutions might come out, but we have little knowledge in the way that the reasoning actually took place inside the models, because they are highly complicated mathematically and most of the time impossible to trace So it doesn't make a lot of sense to people that are not experts in the area. Try to explain the function of a neural network to somebody in the regulatory space or somebody into auditing a system, which is not necessarily expert in machine learning or data science. And then you might agree with me that the opacity there is not even helping at all. Sub-symbolic AI also comes with requirements and computational requirements specifically because they are sometimes challenging in the amount of computation needed. It's also, I'm sure if any of us in here have been working with these models, it's kind of like very concerning having to wait for days and days and days for a machine learning algorithm to obtain results. The training of this system sometimes consumes a lot of time, a lot of data, a lot of computational resources, which sometimes is not attractive anytime that we have a problem to tackle in a limited amount of time. So I think that the advantages and the challenges in both paradigms are very clear. I think they have been very well studied as well. But as I mentioned earlier, both approaches have proven to work and have proven to have also their highlights. And for example, during the last decade, the world of machine learning has evolved drastically. We're actually at a moment in computing history where we can claim that we have been solving problems that was unimaginable. But again, sometimes we cannot explain how computers are yielding into solutions of that type. For example, if you check on the blueprint of the White House in the United States for the explainability and the future regulation of AI, one might check that one of the most important points is the right of explainability. And most of the experts in the area, are actually predicting that the artificial intelligence of the future will have to explain, and that will be definitely non-negotiable. So the question it's the following: how can we continue having systems based on sub-symbolic AI or machine learning that are good at what they do, but not capable of explaining, not transparent, acting as black boxes, and we being okay with that? On the other hand, how can we also know that there are symbolic approaches that are amazing at explaining, extremely transparent when coming up with decision making as a human who have done it, but they are actually not that good at prediction or accuracy or handle uncertainty? So the issue of transparency and the issue of making these systems, not biased, and making these systems appealing to people that are not in the computer science space remains an open research topic. And I appreciate when my student asks me that question in the middle of the class and actually make me reflect about the need for having more techniques that are at the intersection between symbolic and sub-symbolic reasoning and overall artificial intelligence. In my opinion, one of the most important research topics of the future of AI is the creation of more interpretable models. An interpretable model is not necessarily an explainable model. Explainable artificial intelligence, it's the ability of coming up with explanations, but it doesn't mean that the model necessarily is interpretable. Interpretability means that the model by itself at the core of the design has trust, has openness, has the ability to show to anybody how a decision-making process actually works from beginning to end. And unfortunately, this is not an easy path to follow. We have a big challenge in front of us. Creating interpretable models is not an easy task, but it's a necessity. And my research and the paper that I wrote for this conference speaks about what can we do to create more models that are living at the intersection between both symbolic and sub-symbolic artificial intelligence. Yes, there have been works working on the explainability, and an example that I would like to highlight in today's presentation, it's many works that we can find on the literature. For example, trying to create rule-based systems from very well proven to work artificial neural network systems. And an example of that is once we have an artificial neural network working with a high level of accuracy in the domain, we have the ability to try to patch it, the model, creating like another model, potentially trying to understand the functioning of the neural network and potentially mimicking the reasoning model and coming up with rules. Why rules? Well, that's an easy question. Rules because they are simple. Most of the time, they are working with discrete variables. Most of the time, they are very clear about tackling a pattern analysis because we understand rules from a human standpoint. Most of us understand if then else rules. And I think rules are amazing to generalize any type of knowledge that it could have been discovered by another complicated model, call it an artificial neural network, or call it a super vector machine, or call it any other one that at the core, it's acting as a black box, but a potential rule-based system could be helping at explaining how a system is getting into a given decision. But again, explainable models might not be enough. We actually have a big necessity of investing a little bit more research on creating interpretable models. In the paper, specifically in my research, I am proposing that anytime that is possible, that anytime that it makes sense, instead of using artificial neural networks, for example, and trying to patch the system with rule-based for trying to provide some level of explainability, we could actually include, or we could actually consider working with interpretable models. And a model that I have been researching on lately is called fuzzy cognitive maps. I do believe that fuzzy cognitive maps are one of the potential examples that is working like a hybrid approach, dealing with both the characteristics of a symbolic and sub-symbolic artificial intelligence. And let me explain a little bit more what a fuzzy cognitive map is. It's a structure very similar to a graph. It's a graph-based representation, we could call it that way. It has been inspired on any connectionist model similar to regular feed-forward or recurrent artificial neural networks, but with a huge difference. Typically, artificial neural networks are characterized by containing hidden models, hidden layers, and a lot of hidden variables with no meaning at all. These variables are necessarily for the computation, and they are necessary for letting the system run backpropagation, gradient descent, and many other algorithms that are essential for the networks to learn from data. But again, they are introducing a lot of darkness to the model because then they are not helping at explaining how a prediction happened through the model beginning to end. Fuzzy cognitive maps do try to use the best of both worlds by allowing these weights in between variables to make the magic in which we're still training the models using algorithms like backpropagation or equivalent, but every single variable in the model actually matters. Every single variable in the model actually contains an interpretation and a meaning, so that if anyone actually wanted to go back and understand the functioning of this system, that wouldn't be of any problem at all. We could be showing anyone from beginning to end the whole reasoning, and then therefore the model will be way more transparent than a classical neural network. The weights are based on fuzzy logic interpretation. We already know that fuzzy logic, it's actually more natural than working with this discrete of representation. For example, sometimes 0.99 cancels greater than one question, or sometimes 1.001 cancels unequal to one question. And fossil logic actually aims to take into account all of these variables. So incorporating a little bit of fuzziness to handle ambiguity in the creation of the connection in between variables, it's also capturing the essence of the real world scenarios and complexity. There are many algorithms and a lot of literature as well in the functioning of fuzzy logic, but sometimes it's a little bit complicated to integrate it with different other models, call it artificial neural networks. Fuzzy cognitive maps do actually take advantage of fuzzy logic in a simple way, trying to let the expert express their ambiguous representation of information in a natural way, so that we could be connecting variables in a very easy way, respecting the connectionist approach in between variables, and at the same time allowing labels like high, low, greater than, simpler than, more complicated than to be the ones that are used by experts and easy to be labeled in a system. I do believe that the level of knowledge that this representation can capture are much higher than other traditional machine learning models. Therefore, I'm actually very excited to see more models like these replacing black boxes and allowing for more transparent implementation without sacrificing performance and without sacrificing the accuracy of typical and excellent models in the machine learning world. Recently, I have been working a lot with fuzzy cognitive maps, and I have been trying to prove that at certain problems, they can actually work at the same level of efficiency in comparison to other typical machine learning models, and at the same time, they are interpretable and there's no need to patch any explainable system. There is no need to have a secondary system trying to mimic an explanation, because explanation is actually at the core of this model, given the simplicity of the representation and the handling of information at the core of the technique. In conclusion, I would like to highlight the need for thinking about the future of artificial intelligence. I am actually proud of the advancements that we obtained recently. I'm actually defending of the community when it comes to machine learning. I do teach machine learning class. I want to make that point very clear. I am by no means against the usage of this algorithm, but the question is, what will happen when explainability is a right? What will happen when regulations and even governments might be getting involved and asking companies not anymore to trust black box systems, even if they are performing at a good level? What will happen the day where every citizen have the right to ask for an explanation, even if companies do not have a model which is explainable or interpretable? Therefore, I hope that this presentation is actually helping you to reflect that there should be more work on hybrid artificial intelligence, hybrid approaches that are not sacrificing accuracy, but are taking into account explainability, because that will be not only cool, not only important, but most likely necessary and even mandated, as I see the future of AI invading many different applications on the industry level. In my opinion, tackling a problem from the very beginning, thinking about explainability and interpretability, is going to make a big change. Researchers for many decades have been thinking and prioritizing accuracy. They have been putting more, I'll say, the numbers before the explainability of the system. I think that has to change, and I'm very excited to see that the community is shifting into that path. I see a lot of works recently done on more interpretable models, and I do hope that that is the trend as we are trying to reshape the world of artificial intelligence. And artificial intelligence seems to be reshaping the business world, society, and humanity as an overall. So with that said, I would like to conclude my presentation, inviting everyone to next time that we read an amazing paper on machine learning, we also ask ourselves if not only the level of accuracy seen in the paper are very relevant, which deserve an applause, but if the models that they are creating can explain to users how the decision-making process actually happened, and even better, if they have been taken into account their interpretability from design, from the very beginning of tackling the problem into consideration. Thank you, everyone. One more time, Maikel Leon Espinosa from the University of Miami. And I would like to just show my email in case that anybody would like to reach out later on at any times to have a conversation about explainability and interpretable models and the possibilities of creating more hybrid models in the world of artificial intelligence. Thank you, everyone, for your attention and your time.